Hey, Accelerate Algebra 2 Stirrup here. So we're going to talk about some of these where we're shading different regions. And I know on the notes that you don't necessarily see a difference in lines, but hopefully with the video you see a difference with the lines. So let's take a look at what we're doing. So introduction to piecewise functions and graphing piecewise functions. Warm up, describe the two shaded regions in terms of x. So if you had negative infinity down here, the green would be negative infinity to 3. And I don't know if we would include it or not. We'll just make it rounded brackets. So that deals with this region. This region here deals with from 3 to 7. And I don't know if there would be dots here or not. I would say let's just call these both open dots so we'd call it safe. So we have that taken care of. Okay, so piecewise function. So we have f at x equals 2 and f at x equals 3. So we have these two things to think about. So those are both horizontal lines. But we want regions where we're talking about where we're less than or equal to 2 and where we're greater than 2. Okay? So a function made up of multiple pieces of functions. So meaning, remember, a function has to pass the vertical line test. That means the domain itself doesn't repeat itself. Okay, so we're just kind of going over things. So we have multiple pieces, and this doesn't have to have an equal here. You can have an equal down here. So those are all the parts to the piecewise function. So let's take a look at what these graphs might look like, and maybe we can start deciphering how to work these. So what are the equations of the two lines? Well, you have f at x is equal to 5, and you also have f at x is equal to 3. So there's two of them. But you're bound by this one, and you're bound by this one. Okay, so they're not going to overlap. Where is the border between the two lines? The border happens to be just at 2. Okay? And then which line is on the left? If I had 5, or y equals 5, or f of x equals 5, so that would be on the left side of our graph. So let's see what this is going to look like when we actually graph it. Okay, so let's deal with this. The first thing I want to talk about is I want to talk about these numbers here. So let's identify where that takes place. And I'm just going to put this dotted line right here. It's not really part of the graph, but that gives us two sides of the graph that we'll be dealing with. Okay, so I'm going to do this one in red. So 5 in red, so I'm going to count up 5. So 1, 2, 3, 4, 5. I got 5 up here. And I want values that are equal to, so I'm going to put a solid dot here, and less than 2. So that's what that piecewise function looks like. Okay, the second one, I'm going to go ahead and do in blue. So I'm going to go at 3. So 1, 2, 3. I have 3 here. So I have an open dot here, and I'm going this way. The pink dotted line is just the barrier where it changes graphs. You go from one graph to the other. Notice on the red one, we do include the point because we have the equal sign. And on the blue one, we have an open dot because we don't do that. Okay, so let's evaluate. So f at 10. Well, where does this fall? Well, that falls into being greater than 2. So what does f at 10? Well, that falls with the graph of 3. F at 0 falls into this category. So what's the value of our graph there? It's just 5. And then at f at 2, that falls into this exact one because we have the equal sign there. So f at 2 falls with the red, which we said was 5 as well. Okay, so you're dealing with one line or the other. Remember, you're just getting the y component out, the y component out, and these is just a numeric value. Okay, let's take a look at this one. Again, we're going to take a look at this, and that's taking place at 2. So again, this imaginary pink dotted line.
Good morning, Cherry Creek High School faculty staff.
So that's where our graph is changing direction. So this top one, we have a horizontal line at -1, but we are going to be down here. So I'm going to be a solid dot because I have the equal sign. I want values that are less than 2. So that's what this first one looks like. The second one, I'm going to have an open dot at 1. So again, we have these two horizontal lines. And again, I'm happy to go over this in class when you come during the week. All right, so f at 8. Well, that falls into this parameter. So what is my y value there? It's just 1. F at -4. Well, that falls into this region. So f at -4 is -1. F at 2, that also falls into this exact region because we have the equal sign there. So that's going to give me -1 for an answer. So we're going to take a look at these. We're not even going to graph these now. We're just going to evaluate it. So f at 10 is where it's greater than 2. So I normally had this equation, but what am I plugging in? I'm plugging in 10 there. So I'm going to get 3 times 10 minus 2, which is 30 minus 2, which is going to be 28. So that's my answer there. F at 2, that falls into this category because we have the equal sign. So that normally was 5x, but I'm going to plug the 2 in there. So I'm going to get 10. There's my answers. Now we want to graph these piecewise functions. Okay, first thing I want to do is I want to take care of our line. So that's at 3. So I'm going to count over 1, 2, 3. So we're at 3 right there. Okay, that's where it's going to change direction. So the first one I'm going to graph 2x minus 1. So graph it just like normal. I have a y-intercept here at -1. I'm going to go up 2, right 1, up 2, right 1, up 2, right 1. And this one would be a solid dot, so we want values less than. So I'm going to go ahead and graph that. Okay? Notice I didn't keep going. I just wanted where that graph would exist less than or equal to -3. That's why there's a solid dot. Now we're going to graph this one. So I'm going to graph it. I'm just going to graph it like normal, up 3. So I have a dot here, so I'm going to go down 1, right 1, down 1, right 1, down 1, right 1. This is an open dot, down 1, right 1, down 1, right 1. And that's where this piecewise function exists over here. Okay? Again, we can go over that in class, talk about it a little bit more when we are actually face-to-face. Okay, piecewise functions. Okay, again, I'm going to take a look. I'm going to make that happen at 1. So that's happening at 1 because of our parameters. So let's graph this one. So that has a y-intercept at 0. I'm going to go down 2, right 1. That's going to be an open dot there. And I'm going to go down 2, right 1, down 2, right 1. We wanted values greater than 1, so it has to be to the right. And on my second equation, I'm going to go ahead and graph this one. So that has a y-intercept of -3 down here. I'm going to go up 1, right 1. So now I'm going to put a solid dot. And that looks just like that. And those are my two piecewise functions. Now let's take a look at this. We have 4 functions we're graphing. So we're going to take care of a few dotted pink lines. So I have -8. -8 should be here. So that's at -8. I'm also going to have it at -4. Again, these are not part of the graph, but I'm just using this to show where we're going to change directions or change our graphs. We already have the -4 on the other one, then I'm going to have it 0, which is right here. And then next one looks like 4, so 1, 2, 3, 4. And then it looks like I'm at 8 for my last one. So 5, 6, 7, 8. So we're going to have parts of the graph that are in between each of those. Okay, so let's go ahead and graph this one. It's a horizontal line at -3. So down here, -3, 1, 2, 3. We have a solid dot at the 8. We have an open dot at the 4. Okay, and then the next one, we're going to grab 0. So that's going to go between -4 and 0. It's going to have a solid dot here and an open dot at the 0. And then I'm going to go ahead and graph this one. That's at 3, horizontal line at 3. That goes from 1, 2, 3, solid dot here to an open dot over here. And then my last one, what I use green. And then I have a horizontal line at 6 between 4 and 8. So 1, 2, 3, 4, 5, 6, solid dot here, goes here, open dot down there. And this piecewise function, this is called a step function, that is taking place right there. Okay, again, we can go over this when we're in class. Make sure if you have any questions. So have a great day, everybody. Take care of one another. Bye-bye.